Shall we start, sir? Panda sir, can we start? Panda sir, can you able to hear me, sir? Yeah, yeah. So, a very good afternoon to all. So, on behalf of whole organizing team, I welcome you, sir, for the second keynote speech on today's second keynote speech. The speech topic is recent advance in signal processing and communication. A brief bio about Professor Ganpati Panda is Professor Ganpati Panda is currently working as a professor and research advisor at C.V. Raman Global University, Bhubaneswar, India. Professor Panda served as a Deputy Director, Dean Academic Affairs, and Head School of Electrical Science of Indian Institute of Technology, Bhubaneswar. He was also Dean Administrator, Head of Electronics and Communication Engineering at National Institute of Technology, Rourkela. He was a member of Board of Governors of IIT Bhubaneswar and NIT Rourkela. Dr. Panda also served as a Director of National Institute of Technology, Jamshedpur. He worked for 48 years of teaching and research in leading technical institutes in India. He did his postdoc research work at University of Edinburgh, UK in 1984 to 1986 and PhD from IIT Kharagpur in digital signal processing. He has guided 42 PhD in this field of signal processing, communication, artificial intelligence, and machine learning. He has published more than 380 research papers in various research journals and conference with 11,207 citation, H index of 52, I-10 index of 173, and as of 2nd February 2022. So on behalf of whole organizing committee, I welcome you, sir, to this conference. Over to you, sir. Sir, you can start. Sir, you are not audible, sir. You are not audible, sir. You are.
Hello.
Yes, sir. You are able. We can able to hear you. Your screen is not shared, sir. Panda, sir, your screen is not shared, sir. Can you able to reshare your screen, sir?
Screen sharing is not happening. I think. First disable. Can you enable?
Yeah. Okay. Okay. I'm
Share the screen.
Yeah. Yes, sir. I'm doing that. One. Sir, you are now the host. You can able to share, sir. Please share your screen.
Okay.
Yes, sir. Yeah.
Am I audible? Should I start?
Yes, sir. We are audible.
Thank you. Good afternoon to all of you. Sorry for the initial inconvenience. Let me thank Dr. Deepak Panda, the General Chair of AISP'22 Artificial Conference. I am thankful for giving me the opportunity to speak for 1 hour. In the morning inaugural session, I could not participate because there was an urgent meeting I had to attend. I'll make my lecture very simple. I am sure and confident that at the end of the lecture, you will get an exposure about the recent advances in signal processing. Now, my talk I will split into 2 parts. Part 1, recent advances in signal processing. I will not go to the communication side. Second part, intelligent data analytics, which talks about the artificial intelligence. So these 2 I'll be covering through slides. Please be attentive. I don't know how many people are participating. Mostly I was checking around 17, 18. So now around 20 people. 20. Okay, let's see. What is a very, I work in the field of signal processing. People know me in the country. I give a very simple talk. I request all of you to be attentive. Slide is not sitting.
गीजर बंद कर देना बेटा। नहा के धूप में आ जाओ। कॉन्फ्रेंस चालू हो गई। मेरा अभी नहीं है टर्न। चलने दो। मेरा भी आएगा।
Share the slides.
लंच में क्या बनाओगे?
Thank you. So my talk will cover 3 parts. First part, introduction. Part 2, applications. And third part, either it's taken by INSPIRE techniques or I go for fundamental of artificial intelligence. Introduction. Basically, today we talk of machine learning, deep learning, so many new things, artificial intelligence. But to me, I feel it has started from signal processing, adaptive signal processing. So today, when we talk about development of a system, it comprises of 3 things. System can be fixed, doesn't change. Fixed systems are not very helpful. Then subsequently, adaptive system, adaptive signal processing came into being, where the system can change, the system can adapt depending upon situation. But the system cannot change as and when it likes. If you allow, give a direction to change, then the system changes. That is covered in adaptive signal processing. Subsequently, because of the development in artificial intelligence, intelligent signal processing came into being. Now, the learning algorithms which are being used in adaptive and intelligent signal processing are of two types. First are derivative based. The least mean square algorithm, recursive least square algorithm, and a host of such algorithms are derived by minimizing the square of the error. Therefore, it is called derivative-based learning. The derivative-based learning has a tendency to fall to local minima. The solution obtained are not the global solution. Therefore, the another types of learning which has come to the world are derivative-free learning. The biologically inspired techniques, the evolutionary computing are the methods which are part of artificial intelligence, which can update a system. That type of system, we call it intelligent system. Therefore, the total signal processing can be subdivided into fixed signal processing, adaptive signal processing, and intelligent signal processing. Now, on the fixed signal processing, which we teach to the undergraduate student, comprises of filter design, spectral analysis, different types of transforms, Fourier transform, wavelet transform, varieties of transform. Then we use KLT is another types of transform. Effect of finite register length, detection and estimation, higher order statistics. So these are the broad spectrum of fixed signal processing. Subsequently, adaptive signal processing came. This has become very, very important because none of the system can perform well when the input situation changes, when the temperature changes, when the environmental condition changes. Under that situation, the system to be developed has to be adaptable. Adaptive system has two phases of learning. One is the training phase, second one is the validation phase. And after a system passes the training phase and validation phase, then the system is employed for real-life application. The types of training system that are being used are least mean square algorithm and its variants. Recursive least square algorithm, which is more powerful, but sometimes falls to local minima. These algorithms are derivative-based learning, adaptive lattice filter, transform domain filtering, support vector machine, particle filtering. They all come under the category of adaptive signal processing. Subsequently, intelligent signal processing, which we call it amalgamation or hybridization of artificial intelligence and signal processing. Today, most of the research work that is being carried out, whether you are in electrical engineering, electronics, computer engineering, even in mechanical and civil engineering, people are being used intelligent learning, intelligent system, artificial intelligence, machine learning, and deep learning. Basically, to make decision, to arrive at a solution. Under intelligent signal processing, the first one that comes is subcomputing. Second one is evolutionary computing. Under subcomputing, you get artificial evolving. There are, to my knowledge, more than 20 types of artificial neural network that are being used in the practice. But remember, I'm telling some of the highlight R&D problem. Today, the types of artificial neural network like MLP, like FLAM, like radial basis function neural network, recurrent neural network are not actual model of the brain. Brain comprises of biological neuron can be modeled effectively by a new model. This model, some of you might be hearing, this is spiking neural network, SNN. Spiking neural network is the future. These models are being employed for various applications today. The next category is evolutionary computing or biologically inspired. Under this category, genetic algorithm, particle swarm optimization, and colony optimization, bacterial foraging, etc. are more than 50 such algorithms which are being used. These sets of algorithms primarily used for optimization, mainly either maximization or minimization. This can be single objective or it can be multi-objective. These are population-based learning. There is not a single solution. So the chances of falling to local minima like derivative-based learning are not there. The third category is the fuzzy-fuzzy. So basically under soft and evolutionary computing, three main components are there. First one, neural network. Second one, evolutionary computing. Third one, fuzzy-fuzzy. I'll go little more details after I cover it. See, in case of adaptive system, the input can be parallel in the first diagram. In the second diagram, the input are serial. Both have weights or coefficients. These coefficients are adjustable. These coefficients are trained. This training is done by least mean square or recursively squared peg algorithm. Now, there are three important applications of adaptive signal processing. One is system identification or parameter estimation. Suppose there is a nonlinear system, you can make a model of the system such that the response of the nonlinear system yk and the response of the model that you are developing, which are kept parallel to the physical system, that is y dash. And this, when the training is complete, yk and y dash k, that is the response of the nonlinear system and the response of the model, both will be equal. If they are not equal, they are compared, and then the error is produced by taking the difference. The knowledge of this error used through some learning algorithm like least mean square, recursively square to update the model parameter. The training process continues until the square of the error reduces to 0. This is system you can able to make an electrical equivalent system of a physical model. It has a lot of potential applications. The second one, that is very, very important application in communication, is channel equalization. We transmit some data from one point to a parent through some physical channel. During the process of transmission, additive noise are introduced. So in the receiver side, you get a contaminated signal, corrupted signal, low SNR signal. To recover back the signal, we try to make some processing. That processor mostly is called equalizer. equalizer is an inverse filter which tries to compensate the wrong thing done by the physical channel. So equalizer tries to reproduce the transmitted signal escape. But if you do not get escape, then in the training process it continues until transmitted signal and the received signal are both same. So this is the block diagram of a channel equalizer. It has a lot of potential application today in almost all communication fields. Part B. Part B, I discuss about various applications. Each available in digital signal processing. The advanced signal processing has these types of various applications. It is used for optimization, used for prediction or forecast, used for classification, clustering, used for pattern recognition, system identification, inverse modeling, active noise control. We can keep a noise, wireless sensor network, distributed network, intelligent sensors, hearing aid design, medical diagnosis, natural language processing. On each of these important latest application on which the research is going on, I'll cover very little time on each of these. I clarified in the beginning that I'm not going to the details of my talk. Each one will take a couple of hours, but I'll make an exposure to the participant so that those who are carrying out the research in the respective field can contact me, and I will be in a position to help all of you. First one I will cover active noise control. Our group is very active. So noise is of two types, passive and active. Passive noise, which are produced by the silencer. This noise can be cancelled by developing a physical mechanical device. But when the frequency is very less, the length of the pipe, length of the silencer will be very large. Under that situation, you have to go for active noise control. Active noise control is based on adaptive signal processing. It can kill a noise. And this active noise control has a potential application. Basically, if we look to this diagram, the noise waveform is the red one, and the processor active noise control produces anti-sound, which is equal in magnitude but opposite in phase. If both are superimposed, as you are seeing the black diagram, then the net energy is cancelled, and therefore there is a depression, suppression, or reduction in the noise. A lot of work is going on in the world, just like you see our grinder sound. If you are working in an industry, a lot of motors are rotating. If your house is on the side of a road, there is a marriage procession or a temple, all the time the sounds come to your house and we become mentally tired. How to reduce this noise by active control? If you look to this diagram, this is noise source. It propagates and it comes to the output. We pick up by a microphone the input noise developed through a adaptive signal processing and adaptive controller, which will produce YN, and this is back to sound signal. This sound signal is equal in opposite phase. The reduction of the noise here is a speaker. become silent or become very calm and quiet. So noise in this way can be killed or suppressed by active method. So there are many issues. One of the issues in the active noise control that the speaker produces anti-noise. From left to right, noise passed. So from the speaker place, both the noise are interacted and cancelled. But what happens if there is a not fully cancellation? A part of the noise from the speaker propagate to the right, also propagate to the left. And this noise again picked up by the microphone. And in this way, in a recursive method, the noise doesn't get cancelled. Therefore, the feedback effect of noise are to be understood and to be suppressed. We did a lot of work. We use different types of new algorithm to suppress the feedback noise. This, for example, filtered XLMS is one of the very important simple learning technique which are being used for cancellation of the noise. FXLMS, FXRLS. So these are the new types of learning algorithm which are used for active noise control. So many applications, pipe noise, interior noise, free space noise. I can give an example. In the railway station, if you are going to talk to your house, the train has come, I am going to board my train. This background noise of the train and the station go to the far end to your house. It is very difficult to understand under noisy condition what you are saying, how to suppress the background noise. Personal hearing problem. I'll tell you later on, I do not hear through my ear. Therefore, I have undergone cochlear implant as well as using hearing aid or enable me to listen. So how to design and develop hearing aid intelligent type so that you can save the life of many people. So there are many potential applications of active noise control. These are our group. See, each of the case, I'm not speaking like that. Our group people are very active in research. We published many papers in transaction, mostly in ACI Journal and Transaction. Nitin George, D.P. Das, and a host of people, around 5-6 people have done doctoral work under me in IIT and NIT Rourkela. This paper you can see for your Ruchi Kukde from IIT Bhubaneswar, Nitin George from IIT Bhubaneswar. So these are many of the good papers you can see as a reference. Next important application, sensor network. Wireless sensor network has a lot of application. So it comprises of low cost, low power, multifunctional, and small sensor nodes. But the problem is, each of the sensor when try to transfer the information because of their tiny nature, the power associated with the sensor goes down and they do not work. They become dead. How to improve the energy or the power or shape of a particular sensor is a challenging problem. So many issues, how to coverage the full area with less sensor, and many types of optimization, location problems are along with security problems. These problems also we have addressed in our group at NIT Bhubaneswar, NIT Rourkela. So these sensors are used for many applications in agriculture, to know the health condition of agriculture, tracking in battlefield, safety, environmental monitoring, manufacturing, and so on. So basically, these applications, lot of benefit people will get if they deploy the sensor. I'll give an example that in the bridge monitoring, if any of the bridge or building is going to collapse, much before that, you get the information through sensors, how to deploy, and most important one, landmine detection. Yes, in certain areas, landmines are placed, and when the public or the soldiers, they pass through, there's a explosion. A lot of lives and properties are wasted. Can you detect the location of the landmine by sensor network research? Very interesting research topics are there. This is bridge monitoring. If the bridge is going to collapse, at which point, when it will collapse, you can monitor through sensors. Many applications, but there are two types of learning, distributed learning. Today, in signal processing, distributed learning has become very, very important. What is distributed learning? Data is not available in all the 4 nodes I'm showing you. Few data is available in one of the node 1, some data in node 2, some data in node 3, and so on. And these data are all not available in one place. So how to run a machine learning program so that it will give the global solution instead of local solution. For this purpose, it is distributed learning with less amount of data. The parameters are updated, and the updated parameters move to the next node. Next node uses its own data up to date, update the result, send to next node. So in the incremental manner, if this process is followed, a time comes when each of the node are optimized. Each of the node, they perform the best. Therefore, this types of learning is incremental learning, diffusion learning. This incremental learning and diffusion learning are the future, because the data cannot be transmitted to a single place. Data to be processed, whatever you have got in its own place. Therefore, data transmission has to be avoided. Now, this distributed signal processing has many, this is incremental learning. I'm giving you only exposure. So with the less data passing from node to node, the global solution is up. The other one is diffusion. In case of diffusion, each of the node, they update the solution and they send the solution to a cluster head. Cluster head average the solution and send it back to each of the node. This process is repeated until you get a global solution. Those who are interested in sensor network, they can learn incremental learning and diffuser learning for their research work. We did a lot of work in our lab and published many papers. Next important application is intelligent sensors. Today, it is a sensor, world of sensors everywhere. Because of this IoT application, sensor has become very important. Sensor has become tiny, reliable, cheaper. Now, how to deploy the sensor and how to collect the information, it possible if you will make the sensor intelligent. The sensor should have some problem, that's a linearity problem, that the input to the sensor and the output are not proportional. Therefore, we have addressed that problem, non-linearity. That is, if you are applying a pressure sensor, then the diaphragm is bent. Once the diaphragm is bent, then the linearity relation between pressure to capacitance is no more there. Pressure is not proportional to capacitance. Therefore, you cannot have a direct digital readout. To alleviate this problem, many research are being conducted. Our group at IIT Bhubaneswar, we made this study. I'll give an example. Generally, most of the sensor should have a linear characteristics. Input pressure, output is capacity. But you see, in reality, we get this band curve. Therefore, how to compensate the effect of this nonlinearity? A lot of research we developed and utilized successfully the intelligent sensor, which linearizes the input-output relation. What we use different types of neural network. We use different types of multi-layer perception, function of the artificial neural network, and radial basis function network, and as well as farm to find out how we can able to model a sensor, the non-linearity of the sensor. And we can able to model at different temperature, at different time. And we did the inverse modeling. We studied the inverse model. This is sensor which is non-linear. We make a model which is inverse to the characteristics of the sensor. And both are connected in series. Then the non-linearity introduced by the sensor gets compensated in the model. Therefore, these types of application is very, very important. For example, at three different temperature, if this is the characteristic of the sensor, we do the reverse one. This one, that inverse model produces. So the net one is this linearity. So there is a linear relation between the input and output. So directly, digital readout can be obtained. Sensor, to make it linear, is a very, very important issue today. Otherwise, whatever reading you are getting from the sensor are not correct. We, a group of people in NIT, Raukelan NIT, working under me in this area, we have published a lot of paper on intelligent sensor, and most of them are IEEE transaction. You see, these are all IEEE transaction paper. This work, you can have a look, because today, for healthcare, for IoT, for cloud computing, intelligence sensor plays an important role. So those who are interested, you may contact me. Hearing aid. I also work in the area of hearing aid. When you are not able to hear through our ears, signal is not going, or the signal strength is very weak. Now for this, we made a lot of study, and today we can able to develop intelligent sensors. Now look to the sensor. The input is coming. Now the input signal picked up by the microphone gets amplified, and this amplified signal goes to the diaphragm. This is conventional. But the position of the microphone and the position of the speaker, both are very close in practice, because the space in the ear is very small. To alleviate, so what happens, the amplified sound of the speaker are fed back to the input microphone. And this process continues, and this acoustic feedback problem creates losing of the intelligibility of this picture. How to alleviate the acoustic feedback problem? We solve all these problems. Vasundhara, who is did PhD in IIT Bhubaneswar under me, yes, is now a faculty at NIT Warangal. So these papers you can have a look to further your knowledge on intelligence sciences. Now, diagnosis, healthcare. That means many of the patients in the rural area cannot come to the city for treatment. Either they are financially very poor, secondly, distance is large, thirdly, they don't know where to come for which doctor to meet. So healthcare from a distance has become very important. If there are small applications and devices which can sense the various parameters of human body, and this information propagate to the central place where expert doctors are sitting, then immediately, by virtue of the computerized diagnostic system, the disease can be identified. And the doctor being in the city can give direction to the patient who are staying in the rural area how to improve their health. So healthcare in the rural area from distant place are the future. Many sincere attempts have been done to overcome this problem. And the field on which we work is retina image analysis. Basically, in the eye we cannot see because of some types of disease in the retina, glaucoma. So how to detect the glaucoma at the early stage so that proper care can be taken? Glaucoma detection by normal visual or by the simple image processing is not possible. Therefore, how to do intensive image analysis to locate the position of the glaucoma? We worked at IIT Bhubaneswar and we did a lot of very interesting study in this area, and we published a lot of papers in this area on glaucoma detection. Another field which is very important is natural language processing. Natural language processing, yes, is the future. How to understand a paragraph. Human being is able to understand speech, to understand, and when we speak something, how to get a printout. That is, it introduces character recognition, word recognition, sentence recognition, and these techniques many work has been done in different language, but still we are not perfect. How to improve these types of natural language processing devices. And many work we used to do, yes, at both NIT Rourkela and IIT Bhubaneswar. And we try to extract the feature, then we try to get the transformation and try to do the classification, and then try to recognize the various letters. Even from a paragraph, you can able to understand what is the purpose of that paragraph. So these various handwriting we are writing, and it varies from person to person and for different languages, how correctly you can identify this and extract the meaning of the sentence. So natural language processing, I feel, will take hundreds of years now to do a lot of the real life work, because when I speak something, you are able to understand, but a machine do not understand. How to make a system or techniques so that the machine can understand and speak according to the need, intelligent, natural language processing. Now many classes we do it. One Kalyan Das and myself and another my colleague and the Puhan, we have done a lot of work in this field at IIT Bhubaneswar. Now I'll make a gap of a couple of minutes and I'll switch over to intelligent data analytics. At the end of this lecture, I've given you a host of my publication. Yes. So on the communication side, I'm not going, but cognitive radio is one of the very important. Cognitive radio, intelligent radio is the future. That is advanced signal processing of spectrum sensing, spectrum allocation are being employed in cognitive radio. So most of our available smart mobile phone can be replaced now with a new device that is cognitive radio. So this is, we did a lot of work in this field, smart grid and many applications. Now I'll give a gap of couple of minutes and then I'll speak for 15 minutes on artificial intelligence techniques. Give me 4 to 5 minutes gap.
Okay, sir. Oh, no problem.
I want to share my second set of slides. Please help. Is it visible?
No, sir, it's not visible.
Dr. Panda, is it
Yeah,
visible?
yeah, now it's visible, sir. Now it's visible. It's visible now.
Slide. I'm sharing the second set of slides. Is it visible?
No, sir, it is not visible now. You can again reshare it. The screen is not shared, sir. Sir, your screen is not shared, sir. Sir, can you able to hear me, sir? Can you able to hear me, sir? Panda, sir?
So I want to share.
Yes, sir. Yes, sir. I make you co-host, sir. Again, you reshare your screen, sir. Sir, I make as a co-host.
Disable participant screen sharing. Please allow us.
Yeah.
Dr. Panda.
Yeah. Yes, sir. I have done.
think it is visible now.
Yeah, it's visible, sir, now. Go ahead, sir.
No. Okay. Now, this side speak for 15 minutes. Intelligent data analytics. Full screen. I can't able to do so. This is okay.
Yes, sir. We can. Yeah, it's okay.
Basically, today we do whether it is one-dimensional data or multi-dimensional like image or video, we have to analyze in an intelligent manner. This is required not only for the electronics EC people, it is required for all branches of engineering. I will tell you the very, very fundamental of this. So my talk, this 15-20 minutes, will comprise of these outlines. Why we analyze the data? Why we analyze the data? For decision making, for reasoning, for arriving at a solution, it requires analysis of data. The analysis of data comprises of two types: statistical method, operation research method, or mathematical based methods. These types of analysis have some problem. So today, therefore, intelligent based or computational intelligence based or AI or machine learning based techniques are done. The purpose is decision making. The third type is the big data analytics. When the amount of data is more, then you have to use for deep learning and other intelligent methods for arriving at a solution. So basically, when you collect data, or some data is available, healthcare data, biomedical data, pollution data, financial data, manufacturing data, communication data. Now these data are to be pre-processed. What do you mean by pre-processing? Generation of missing data. Some data is missing. You have to create data after creation. You have to normalize the data. Data normalization is required because some data is very large, some data is very small. To give importance to both small and large amount of data, normalization is done. There are various types of normalization of the data. The second one, feature extraction. There are three types of features from the data to be extracted. The purpose of feature extraction is to make the processor faster, to make the classifier or forecaster simple, to make it implementable in online manner. So feature extraction is very important. So the hidden features of any set of data to be extracted. There are statistical feature, transformation feature, and technical feature. All the three types of features are usually extracted. As I told before, I can't. As I told before, I can't. Yes, I can't go details of this. I only taught it. Remember, statistical, transform, and technical feature. Then the feature reduction. When the amount of features become large, you have to reduce the feature. There are many techniques of feature reduction. Factor analysis, principal component analysis, linear discriminant analysis are employed for reduction of the feature. In addition, there are two more things: feature selection, features optimization. These are also being used in research. Now, what are the different types of decision making for operation or actions, usually the whole world is busy. Today we talk of AI for what? For doing these few jobs. There are 7 to 8 jobs. Everybody does research to achieve one of these following, or maybe more than one: filtering, clustering or grouping, forecasting or prediction, classification, parameter estimation or system identification or pattern recognition, direct modeling of the system, inverse modeling, deconvolution, channel equalization, nonlinearity compensation. Inverse modeling is also used in smart sensors. So these, next one is optimization, either maximization or minimization. Either it is single variable or multivariable. Either it is single objective or multi-objective optimization, with constraint or without constraint. Today, most of our research work, those who are publishing paper, are formulating their problem as a multi-objective, multi-constraint, multivariable optimization. They give solutions which are not only stable, these solutions are optimal. The next one is the detection. So these are the various types of operations we perform in data analytics. Most of our research work attend to this. Now, what are the available techniques for filtering? We can use LMS, RLS, backpropagation. For picture extraction, as I told, PCA already. For clustering, K means clustering, hierarchical clustering, fuzzy C means clustering. For forecasting, we can use regression, logistic regression, nonlinear regression, nature-inspired technique, artificial neural network. For classification, we use neo-fuzzy techniques, all types of neural network, net-based, decision tree, random forest, support vector machine. For parameter estimation, we use same technique as system identification. Yes, we use FLAN, we can use LMS, RLS, different types of artificial neural network. For inverse modeling or deconvolution or channel equalization, we use example center. For optimization, we use biologically inspired, and for detection also biologically inspired. Distributed learning, incremental and diffusion LMS learning. So these are most of the techniques that comes under artificial intelligence to achieve this aid operation. I won't think any other new operation is there which are not mentioned here. Most of our research in whatever field we are doing pertain to one of these operations. So computational intelligence, CR, it mainly comprises of artificial neural network. There are about more than 20 types of artificial. But today, convolution neural network, different types. There are about 12 types of deep learning model, spiking neural network, as I was telling you today. And this whole set of neural network are part of computational intelligence, which are being used for filtering, for classification, for forecasting, for clustering purpose. These types of neural network to develop requires 2 phases of operation. One is training phase, other is testing or validation phase. The training phase can be of 2 types: supervised learning and unsupervised learning. Most of the learning that we are employed are supervised learning. But today, unsupervised learning has become very, very important. One has to learn unsupervised learning when the target signal, desired signal are not known. Coming to the convolution neural network today is very, very important. It's Just a minute. Okay. So basically, CNN is very powerful. It doesn't require the extraction of the feature. Automatically from the input data, features are extracted. It comprises of convolution operation, pooling, and dropout until the last layer, where the last layer is used for prediction or classification purpose. Coming to the fuzzy logic. Fuzzy logic. There are three types of fuzzy logic. The first type was proposed by Latvia in 1965. It is based T.S. Tanaki, Sujano fuzzy logic. This fuzzy logic is based on if then rules. Subsequently, Mamdani fuzzy logic came out. And this fuzzy logic is based on fuzzification and defuzzification. The third one, which is more important, we started in 1990, are the raw fuzzy sets. Those who want to work, better to use raw fuzzy set, which is very powerful. And coming to this AISP' technique, there are more than 50 techniques are there. And we have been using, many of you must have published paper in this conference, presented paper, or will be presenting paper based on these techniques, but these techniques can be single objective and multi-objective. This technique is difficult to use for online purpose because they are population-based learning and that can consume a lot of time, but you get global solution. It can be single objective, multi-objective. And various performance measures like accuracy, sensitivity, specificity, false positive rate, false negative rate, root mean square, value, mean absolute deviation, receiver operating characteristics, area under the curve are the parameters which are evaluated in prediction classification tasks. So basically, I gave an overview of artificial intelligence, which are presently being used for healthcare, finance, agriculture, pollution and weather, multimedia, IoT, sensor network, and cloud computing. These are various application areas of this, and these different types of computing systems are there which you people are using. So I'll stop here. We have got hundreds of publications in standard quality journal on the area of not only signal processing, another 100 papers on intelligent computing. So I think I'll stop here and I request if any of the participants who have been attending, if they can ask me some question, I'll try to clarify. Thank you. I request Dr.
Yes,
to coordinate
yes,
any question anybody wants to get, let them give, let them type and send it in the chat box so that I can able to read and able to clarify these questions. Thank you.
so thank you very much, sir, for your wonderful speech. So I request participant, if you have any questions or any doubts, you can unmute yourself and ask the questions. Anyone having any questions you want to ask? Or you can also write in the chat box also, as per Sir's suggestion. Any question? Anyone having? If no questions, I request all of you, please switch on. Yeah, anyone asking? Anyone asking or something? So if you don't have any questions, I request all of you, please switch on your video. We have to take a photograph. Sir, please, sir, we will take a photograph for IEEE. So I request all of you, please switch on the video once. Okay, so any question? Thank you to all. So thank you again, sir, for accepting our invitation and delivering a wonderful speech. I think this speech will clear all the doubts of signal processing. You are start from basic to the top level, a higher level of research level. So thank you very much, sir, for your valuable talk. We will get back to you, sir, after some. Thank you very much, sir.
Thank you. Everybody wants to question, they can send to you.
Yeah, yeah. I will send. Yeah.
So
Thank you, sir.
for giving the opportunity that the Pika Panda and his group for sharing my thoughts.